Let's go ahead, guys. We're on practice test number 2. Remember, I don't see you tomorrow, so we need to use our time wisely here. So practice test number 2. Don't wish your life away. It will be soon enough, sweetheart. Trust me, it will be Friday. Eli's getting some paper so that he can do this practice test, spread it out a little bit, because that's what we need to do. The last one, the one we do on Friday, is actually designed like the test, with answer blanks and everything.
The test this week or next week?
The test is Tuesday. So, here we go. Number 1, notice, same 5 questions. They're in a little bit different order than they were yesterday. That the same 5 questions. We're on practice test number 2, Antoine. So here we go. We've got an M function and an N function. Okay. Letter A says find M of N of X. Now remember, if there's no number, this problem does not have a number in it. If there's no number, we take the entire equation and plug it in to the other function, right? So we're going to take the entire N function, that equation, and put it right there. This says take the N equation and put it into M. So we're going to have 4 times x squared plus 2 minus 3. If there's no number, we plug in the entire equation. And we plug it in for x. So in place of the x. So we got 4x squared plus 8 minus 3, or 4x squared plus 5. And that's your answer. Don't do anything to it. That's it. All right, so what did we do? We plugged in the entire equation. When there's no number, that's what we do. Okay, second one says M of 2 minus N of 3. All right, let's do M of 2 first. That is a number, so I'm just going to plug it in. What's M of 2?
They say can you let them in?
4 times 2 minus 3. So what is that, 5? Right? Now we got to do N of 3. So N of 3 will be 3 squared plus 2, or 11. And then we're going to subtract them, because that's what the problem says to do. So the answer is negative 6. M of N of 1. Now this one has a number. So we're going to take the 1 and put it into N. So what's N of 1? 3. And then we take the 3 and plug it into M.
9.
So the answer is 9. 12 minus 3. 9. Right. And then the last one says take M of X times N of X. So we're just multiplying them. So we're going to take 4x minus 3 times x squared plus 2. So what am I going to do? What operation? What kind of, I'm going to FOIL. It's going to be a FOIL. I'm just multiplying them. So I get 4x cubed minus 3x squared plus 8x minus 6. When we have that kind of a situation, we don't solve it, we're done, this is it. But do try to have it in good form. So collect like terms, if there are like terms, we don't have any here, but add those together if we do have them, and put it in descending order. So it's going cube squared like that, like that. Okay. Question 1 done. All right, number 2, find the implicit functions. On the test, actual test, there'll be 2 answer blanks. You're going to fill in 2 answer blanks. And it's going to be y equals, right, for both of them. So what do we have to do with this equation? 2x squared, we got to get y by itself. So I'll just subtract the 2x squared. Right? And then what? Square root both sides. So how's come I'm getting 2 answers? Plus and minus. So it's the square root of 6 minus 2x squared, and it's negative the square root of 6 minus 2x squared. No matter what is underneath this radical, are you going to simplify? No, no, no. Because as long as there's a minus or a plus in there, you can't simplify. So I don't care if this number is a 9 and this number is a 4. You're going to be tempted to simplify. Don't. Don't. You can't. You're done already. That problem's finished. All right. So now we have some domain questions. The minute you see that word domain, what goes through your head? What do you know you have to pay attention to? Square roots and fractions. Square roots and fractions. All right? So, very first problem has a square root. It has to be greater than or equal to 0. So, x minus 1 has to be greater than or equal to 0, which means x is greater than or equal to 1. Whatever is under the radical must be greater than or equal to 0, right? Okay. That's all. Now that's done. That's the answer. Okay, now what about the second one? It has a denominator, and what do we know about denominators? They cannot equal 0. So that domain is x cannot equal 1/3. Denominators cannot equal 0. This unit has a lot to memorize. Under the radical has to be greater than or equal to 0. In the denominator cannot be 0. Okay, so let's look at C. What's going on with problem C? All real numbers. Why is the domain for problem C all real numbers? No fraction, no radical, right. Remember, the things that cause us issues are fractions and radicals. If we don't have fractions and radicals, then our domain is going to be all real numbers. 99% of the time. We're not going to do any tricky ones. So if you don't have a radical or a fraction, you're going to have all real numbers. All right. Now, unfortunately, D has both. Right? So, that just means we have to do both parts. So what do we know about what's under a radical? X plus 2? Greater than or equal to 0, so x has to be greater than or equal to negative 2. That goes in the answer blank. But there's another part of it. X minus 3 cannot be 0, so x cannot be 3. So both of those have to go in the answer blank. You're going to get part of your answer from the radical and part of your answer from the denominator. Right? All right, that's done. Okay, so now we're ready for number 4, which is a bunch of sketching. So this is where your BFF work really comes in handy. You're not going to have a calculator to sketch these. You're going to have to be able to sketch these by hand. So, what shape is that? A V. Because it's an absolute value, and absolute values are V's. So we know we have a V. Normally, we would just come out from the origin. That's our normal V. But these numbers have moved it. What does, thank you, we're on practice test 2. What does this do? Notice where it is. It's inside the absolute value. Yes, Ella, it moves it 2 units, actually to the left. And that number outside moves it up. Okay? So if it's inside with the X, whether it's in a parentheses, in an absolute value, in a radical, wherever it is, if it's inside something, it's going to go opposite of what you think. So this is a plus 2, it's actually going to go left 2, and it's going to go up 1. Now when you draw this on your paper, it doesn't have to be anything perfect, but you do need to label that point. That now is the important point. So left 2, up 1. There's my V.
On the test, do you have an instruction to label the point?
No, we just know we're going to do that.
Okay.
So these look like little graphs, or we can make
I'll probably have a graph there for you. Okay? All right, number or letter B. Now these are always a little bit harder. So I'm going to just start with the plain sign. I'm going to start with that. I know there's a plus 2 on that. We'll put it on in a minute. But right now, let's just graph the plain sign. Okay, so what do we know about the sign? What shape is it? It's the wave, and what's special about it? It goes through the origin. Now, I noticed on some of your quizzes, or some of the quizzes, make sure that when you graph your sign, it's a hill first, and then a valley, okay? So it looks like this. So graph your hill first, and then your valley. How high up and down does it go? 1. Perfect. So that is the sign, the normal sign. Now, when you put a plus 2 on the end of it, what does that do? Moves you up 2, right? That doesn't look like this, kids. That would be different, right? This is on the end, so it's up 2. So that means that point right there that was at the origin, the start, is now going to be up here at 2. Right? Everything gets moved up 2. And this, which was up 1 before, is now going to go up to 3. And so your sine curve is going to look like that. Katie?
Do you want the original one on the...
You do not have to put the original one on there. I do, it helps me, so certainly you can if you want, but you don't need to. What I want to make sure you pay attention to is that what's the high point of the new curve? The one you put down is the answer. What should be the highest point? 3. And what should be the lowest point? 1. Because the original went from -1 to 1, right? So if we add 2, add 2, it would be +1 and +3. So that's important that you have it oscillating between the right two numbers.
So are we gonna have to make a point on there and say 0.2?
Well, I labeled my axis, so I don't actually have to label that point, but if I had labeled that axis, yeah, I would.
Do we have to write 3 and 1 just to know the height?
Yep, yep. You have to write down anything that's important to the problem. So, like, you don't have to do -2 and -3 because they're not important to the problem.
The one we went -1 to 1, you want us to write that?
You don't have to.
Okay.
No, I said, somebody already asked that. I used this to get myself started. That's the original curve. That is not the answer. That just helped me. Okay. C. What shape is C? C is a parabola. Right. How do we know it's a parabola? It's a squared, and your squaring function is a parabola. So y equals x minus 1 squared minus 1. So this is another one that's got extra numbers thrown in. So the parabola is not here anymore. What does this tell me to do? It's inside. So it goes right 1 and down 1. So right 1 and down 1. So this is the point 1, -1. Right 1, down 1. And then I can sketch in my parabola. And that's all there is to it. All right, what shape is D? A squiggle. And again, the normal squiggle, I'll do it over here to the side, the normal squiggle squiggles through the origin, right? What have we done? Notice where that 2 is. That 2 is inside, so it's gone left, negative, yep. So it now is going to squiggle through that point. So it's that exact picture, but it's squiggling over here. So it looks like that.
So do we not want to cross the y-axis?
You can, it does up here.
Okay.
So I'm not all picky about that. It will cross eventually up there, yep. That is not an asymptote. All right, and then we've got this. Now that is a very scary looking equation, but if you know your BFFs, this is not hard at all. What shape is this going to be? Square root, and y'all know what that is, or you're supposed to know what that is. That's this, right? But how has it been moved? Left 1, down 2. So left 1, down 2, so it's sitting right here, -1, -2. Left 1, down 2. And then it's that shape, so I just draw that shape. And then the piecewise function. Now, these look big and scary, but they don't have to be if you do them one piece at a time. Okay, so I'm going to start with that top one. I'm going to graph y equals 3x minus 4. What? That is a variation of a BFF, but it's not really a BFF. What? Hi. What does 3x minus 4 look like? It's a linear, mx plus b, right? So I'm going to put a point down here at -4. I'm graphing this thing, so I'm going to be down there at -4. And then my slope is 1, or 1, 3 over 1. So up 3 over 1. Up 3 over 1. And so I'm going to go ahead and graph in this line.
How did you get the top thing? The first one?
I start at the y-intercept, up 3 over 1, up 3 over 1. Slope. Now, I don't want the whole line. This curve is broken. This tells you where it's broken. It's broken where x is -1. So right here is where it's broken. Where x is -1. The purple line, the line I just graphed, crosses that right here, right? Will that be an open dot or a closed dot? Look right here. Isn't that going to be open? So I'm going to open that dot up, make sure it's nice and open. And now I'm going to have to erase a piece of my line. Always this tells you what to keep. So which side am I keeping? The left. So I'm going to keep that little piece down there, and I'm going to get rid of all of this. So at this point, all I have is this little piece clear down here at the bottom.
What's that point where the dot is?
That would be the point -1, -7. Now, what shape is this going to be? A V, but I've stuck a +1 on it, so it's going to go up 1. So that's going to look like this. Now notice it also crosses the red line, it always will. And there's that point right there. Open or closed? Closed. That one's going to be closed. Am I keeping the right or the left? Which way is it pointing? I'm keeping the right, which means I'm going to erase this, which is good because I can't have two pieces on the same side. Here's your dividing line right here, this red thing. That's your dividing line. You're going to have a piece on the left and a piece on the right. And that's it. I'm done. Notice my dots are on top of each other. Always will be.
Right, so those will always be the same with the dash line.
Yep. Yep. All right, only one more problem on the test. And this is the horizontal, vertical asymptotes and holes thing. So let's look at the first one. And you're doing vertical asymptotes, horizontal asymptotes, and holes. You do not need to graph it. You're not doing any graphing here. You're just filling in the blanks. All right, what can you tell me about that equation?
There's no right.
There's going to be no holes. How do I know that? No canceling. If you cannot factor and cancel, you're not going to have any holes. All right, that's easy enough. What about asymptotes?
Isn't there no horizontal?
Actually, there is a horizontal this time. Sometimes there's not, Jaden, but there is this time because to get the horizontal, remember I do the box? So what happens when I put 2x over 3x? Where's that horizontal asymptote going to be?
2/3.
Y equals 2/3, yeah. Y equals 2/3. Remember, you box them in to get your horizontal asymptote. Where does the vertical one come from? The denominator. So 3x minus 4. I know when I do domain, that cannot equal 0, right? So x could not equal 4/3. Whatever x cannot equal is where your asymptote is. Your asymptote's at 4/3. Your vertical asymptote is wherever that cannot be is. Okay? Easy enough. What about the next one? E. Does it have anything? Well, first of all, do you notice that you can factor the top? But it doesn't matter. Very good. It's a good idea to think about factoring it, because what do you have to be on the lookout for? Canceling, right? Now in this case, it doesn't matter. Nothing cancels, so it's okay. That means I have no holes. All right? Zane, I can't see you. David, I can't see you either.
I'll screen each other together.
Okay. All right.
The horizontal asymptote would be 1/0.
Okay, and what does that mean? So Jaden says, to get my horizontal, I have to draw the box thing. But when you draw the box, you have to have the same variable, same power in there. Don't draw a box around these two. That's not right. What you have to do is say, okay, I need x squared. There aren't any on the bottom, so that's how I'm drawing the box. And like Jaden said, that's 1/0, which is undefined, which means you can't have one. 1/0 does not exist. So your horizontal asymptote doesn't exist. There is no 1/0.
Do we put like undefined, or do we have to put?
You write none, because your job is to find the horizontal asymptote. So there isn't one. Now what about vertical? Is there a vertical asymptote?
Yeah.
Where is it? X equals -5. Because vertical asymptotes come from the denominator, what x cannot be. That's your vertical asymptote. All right, now we've got C, which looks like a very big problem. All right, so what do you suggest we do with this?
Factor top and bottom.
Factor top and bottom. All right, so what do you think we should do to the top? First, we probably should take out a 2. And then that will leave us with x plus 4, x minus 4. Now don't forget to keep the 2. The 2 stays in there. The 2 that you took out in the beginning stays. Okay, what about the bottom? How does the bottom factor? X.
X plus 5, x minus 4.
Yep. Plus 5 minus 4. That's exactly right.
There will be a hole.
So we're going to have a hole this time because we're going to cancel, right? And that's the only way you ever get a hole, is if you cancel.
Well, we can still put it in the negative. Or do you
What, Jameson?
we you only cancel both negatives instead of like, I thought you were like, cancel the bottom negative and the top.
When you cancel, the parentheses have to match exactly. They must match exactly. Don't cancel anything that doesn't match. Now, where will my hole be? Well, it's a point, remember? It's a point. The x part of the point comes from what you canceled out. So x is going to be 4. Exactly. X is going to be 4. The y part comes from plugging it in here. So 2 times 4 plus 4 over 4 plus 5. I just plug whatever the x is, and that came from what canceled, gets plugged in. So what is that? 16 over 9? Alright, let's look at our problem now. This is our new problem. This is where we are. Is there a vertical asymptote for that problem?
X equals -5.
X equals -5.
And then
Is there a horizontal asymptote? Now remember, that's when you box it in.
it'll be 2.
It'd be 2. Y equals 2. And you could actually tell that from the beginning if you wanted to. 2x squared over x squared.
If the vertical asymptote was a -5, is that when we would write x cannot be 5?
I don't know what you mean.
Like, in the problem,
Yep.
if it was x minus 5.
Yes, then it would be x equals 5 would be your,
Oh, so we never write x cannot be.
not for an asymptote. But the number is going to be the same. If you were doing domain for this problem, so if the question was domain, you would say x cannot be -5. Whatever x cannot be is exactly what the asymptote is. Okay, so you treat it the same way. Just domain, you're saying, okay, in the picture, I'm not going to have any values at -5. Well, of course you're not, because you're going to have an asymptote at -5. Okay? Those numbers are the same. All right? Okay, so let's pause.